I'm Bob Sandheinrich. I'm a development manager here at Wolfram. I work in the deployed products and services group. And yeah, I'm going to be talking about publishing in our repositories. So if you just saw Stephen's keynote, he mentioned many of the repositories and showed some of them and encouraged people to publish in them. So this talk's going to encourage you further and show you how. All right, so Wolfram repositories and the resource system. So repositories, is the term that we use to refer to collections of a certain type of content that's ready to use in the Wolfram language. So in past tech conferences, we've talked about and promoted several different repositories. I've listed most of the ones that we've had talks on in previous tech conferences here. Data repository was first, and then we've had neural net function, Packlet, LLM prompts, and LLM tools. And so each of these has its own distinct type of content. And then we also use this term resource system. And when we talk about the resource system, we're talking about the entire suite of technology that my team has built to enable these repositories. So that's everything from the website tools that you use to explore to the development tools that the authors use to create and submit content to the Wolfram language functions for retrieving that content. The whole suite of tools is what we call the resource system. And no matter what type of content it is or what repository it is, each resource is always represented by a resource object. So here's an example for Chatbook, which is a Packlet in the Packlet repository. If you've used Chatbooks and all the cool ways to interact with LLMs, that code is distributed through the Packlet repository. And when something is a resource object, you can access metadata directly from the resource object without interacting with the content at all. And some of these properties are consistent across all the repositories. So you can kind of, see what you're going to get before you dive into a resource. But then if you want to interact with the actual content of the resource, each repository or each resource type has its own unique integration into Wolfram language. So since this is a Packlet resource, you can retrieve the Packlet object by just doing Packlet object or resource object. If it was a data resource or a neural net resource, you would interact with the content in different ways. So the content is, the way you interact with the content is custom for each type, but the sort of metadata in the resource object is consistent. So that's, I'm trying to, keep this pretty brief because I want to get to the submission part. So two repositories I want to highlight in this talk are the example repository and the demonstrations project. So let's quickly look at the homepage of the example repository. This existed at Tech Conference last year, but it wasn't really ready for us to talk about much. There were still lots of issues. The content was pretty minimal. But now it's really come along, and so we're excited to talk about it this year. And each one of these is sort of, you can think of it as a workflow showing how to accomplish something or do something interesting in Wolfram language. And since it's cloud notebooks, all of the inputs are copyable and everything will just work right away in any notebook anywhere. So you can put it in cloud, you can put it in desktop Mathematica, and it'll just work. And you can interact with these things as resource objects as well. And the main piece of content for example resources is the example notebook. So you can retrieve the full example notebook from the resource object just like this, and you can evaluate it that way. Sometimes that's easier than doing click to copy on each input from the website. So this is exciting. If you have, if you're looking for interesting examples, explore the example repository. I'm sure that you can spend 20 good minutes there, even if you're just blindly looking around once, and I encourage you to do that. Demonstrations is kind of a special case here, because really it's been around longer than the resource system, right? So the data resource is, shoot, I should know this, 8 years old or something. And demonstrations is another 15 years older than that, right? So it's been around for a long time. But what's new now is that it's been migrated into the resource system. So now, which doesn't really affect the website much at all, but it has a big effect on the authoring side of things. And also it means that you can do some nice stuff like accessing content from demonstrations via resource object. So right now you can sort of use a demonstration the same way you would any other resource object from a different repository. All right, so that's just a brief summary of, sort of exploring repositories and using them for the end user. But what I want to focus on for the rest of the talk is really publishing your content, right? Creating content and distributing it. So why would you take content that you have, say it's a function or a data set, or a cool example like a workflow? Why would you want to make a resource object out of that? Well, there's three main reasons. The first is that you can attach metadata. So like I showed earlier, that the Packlet and the Packlet repository had keywords that concerns the search terms, and you can categorize things, and you can add all sorts of metadata to your resource, to your content, whatever it is. And also you can add documentation, which is critical for the function repository and the Packlet repository, right? You can create the best code that's ever been created, but no one but you will know how to use it without good documentation. And the resource objects provide a way to both write and package up that documentation with your content. So that's really nice. But then the big reason, this should be, bold. Oh, come on, bold. No, okay. Presentation notebooks, I guess, have different hotkeys. Distribution is the big reason, right? This is the real reason why you want to create a resource object. So once you've created your resource object, then putting it out into the world through one of two different ways, which we'll talk about here coming up in a minute, is straightforward. So that's really the best motivating reason to use a resource object. Come on, page down. There we go. All right. So the best way to take your content and turn it into a resource object is to use what we call a definition notebook. So let me exit full screen here. This is a definition notebook to create an example resource. And, it's really straightforward. It's kind of self-explanatory how to use this thing. You fill in a title, amazing new discovery in mathematics. And then, you just fill in this notebook, put your example in here. That's sort of the main event for an example resource, is this example content. There's supporting data. I will show that in a minute. And then a bunch of metadata that will help people know how to use this thing. But since I'm, don't have a ton of time, I'm going to cheat a little bit here and use a pre-filled notebook. So I've filled this one in already, and this is baseball statistics because I'm a baseball fan, so I like to play with baseball numbers. And this one is using a Python library to retrieve the raw data. So here I've created a title, and this, the name up here should be like a title for a book or an article or something, right? So the title case and everything. And then there's kind of these three blobs of text near the top that are special. This one is what we call the description. And it's kind of, and obviously the title is required and needs to be right. And then these other two are optional, and If the title tells people everything they need to know, you can just have the title. But the description can, kind of be more of a active sort of marketing style pitch for to grab attention to your resource, in this case, your example. And then this little very short paragraph can get a little bit more into the details. So this is saying things about how it's actually done and telling you and sort of defining the terms, right? Like this says StatCast, but nobody knows what StatCast is. So I tell you right here off the top a little bit what it is. And then the body of the example here is basically just a sequence of captions and inputs and outputs. And the important thing here is that the code is very simple and readable, right? I don't have any blobs, any monolithic chunks of code that are hard for anyone to figure it out, right? So it's each step is kind of straightforward. And I kind of, I go through, I filter the data, and then I create, this is sort of my first result that might be interesting. And then I do some visualizations. This is a little utility. I put a semicolon at the end here. That's probably not good. I like to encourage people to show outputs unless they're really big and ugly. Especially like this case, it kind of returns unevaluated, which if somebody looked at this output and saw that it was unevaluated, we might think that something failed. So show the output and show that it's supposed to be unevaluated, right? That's really helpful. And so then I have a couple of visualizations here, showing the list of every one of Jordan Hicks's sinkers in his career from the point of view of the catcher catching the ball. And then I do it as a histogram instead of as like this scatter plot. And then this last one is, this isn't how I would do this normally, but I wanted to show this supporting data feature. So what I have here is resource data, and then this little icon, and then this element name, sweeper locations. And what this is doing is this little icon represents the resource object to be defined by the notebook I'm making right now. So it's a self-reference representing this resource object itself. So this is sort of saying the data that already exists and is predefined in this resource. And where does that get defined? And that's right down here. So here I'm defining this sweeper locations using that same icon. And this is my convention where whenever I create the data the first time, I just store it in a file. The file happens to be a cloud object. And that way I kind of know that it's static and I don't have to recreate it again over and over if I, quit the kernel or come back to this another day. It's stored for me in a file. And then I just import it again from that file. So this is a data set with data that I want to use in the example. And then here's where I actually use it in the example. So it's kind of unintuitive in that you're using it higher up than where you actually define it. But you get used to that because, starting to work on the example is usually the first thing you want to do. And then we have this thumbnail image, which is very important for example resources. This is very prominent on the website and kind of is what people will see and will draw them to your example along with the title. But this should be, then there's lots of guidelines, and we will talk about guidelines in a minute as well. But I want this to be square, which luckily this one is. I want it to be kind of a medium resolution, which this one is. And importantly, I want it to be an actually very relevant to the example, right? What we're not looking for is some like cool looking infographic that's not particularly important to the example itself, right? This is an actual output from above. So it's extremely relevant. All right, and then I fill out the metadata. I put my name in. I put in keywords or search terms. I put in categories. One thing that's different about categories and example repositories, you can create your own. So sports isn't a category that exists. I made that one when I filled this out. I could add another one here in this free-form input. And this won't like automatically make a web page in the repository. But we keep track of these, and if we have a handful of them that are all very similar category, well, then we will create it and it'll appear. So it's kind of nice to have that free-form suggested category. I can add links if this only works in specific Wolfram language versions, or if it requires it doesn't work in cloud, or if it doesn't work in like a task kernel. You can mark all that stuff, and then the example will it'll warn people if they try to use it via the resource object in an environment where it doesn't work. All right, so this is sort of how you fill out a definition notebook for the example repository, and it's very similar to other repositories. So once I filled it out, the next thing I did was I hit this check button. And what that will do is it'll go through and it'll analyze the notebook and it'll look for issues. So it says no content has been defined. So this is a tricky thing. So this supplementary or supporting data, in order for this to work, I need to actually, shift enter, evaluate that cell before I deploy or submit it. So I've done, and I hadn't done that yet. So now I've done that, and I'll run check again, and I get this nice check mark, clean bill of health, and so then I'm going to go ahead and deploy it to my cloud account. So let's see, how am I doing on time? I still got some time. So we'll let that chug. That should take less than a minute, I hope. And what that will do is it will make a cloud object in my cloud account that is a resource object that can be used just like an example resource from the public repository. But it's not an example resource in the public repository. You can see my name is here in the URL. So if somebody goes to the example repository and they navigate around, they're not going to find this, right? So anybody I want to find this, I need to send them the URL, right? There's no other like discovery mechanism. But there's also no review process, right? I can update this as much as I want. I can break it if I want to break it. I'm totally in control here. And so now if I'm gonna close this guy. Let me get back to my presentation. So that's a example resource. Let's just briefly look at the demonstration definition notebook. Let me exit the full screen there. So this one is shorter. Again, I'm gonna cheat again and use a pre-filled one. So in this case, we don't really mind big blobs of unreadable data in this case, right? So unlike example repository where the process is the content, right? It's about showing a workflow and how to do something. This one, the demonstrations, it's nice if your code's readable, but that's not really the point. The output is really the point. So here I have another baseball thing where I can show, I think it's Shohei Ohtani, how hard he hits different pitches. So I create this initialization code, which is needed by the manipulate. I create the manipulate. So, these manipulates can be tricky to make, but I'm not going to teach you how to make them right now. But, that's sort of the long-standing magical thing in Mathematica. And then a nice feature I want to highlight here is this add snapshot button. I'm going to click that, and that will make an image, a static image from the current settings in my manipulate and copy it down here. So now I have these 3 snapshots here. And these are useful for the website as sort of a static summary of what you'll see if you use the manipulate. Again, we have very similar metadata section. Notice the categories are different here. There's no freeform inputs, but there are these nested hierarchical categories. And these might evolve over the next month or so. But because this migration effort of demonstrations is sort of ongoing still. There's still things we might want to tweak, like these categories. But you can see we have lots to choose from, so it might take a minute to sort of go through all of them and find it. I can add the names of other demonstrations, but I'm just going to go ahead now and deploy this to my cloud account as well. While that's going, I'll come back here to my notebook. So as I alluded to earlier, there's two ways really to distribute content when it's a resource object. You can either cloud deploy it, which I've now done twice in the last 5 minutes. And as I said, you're totally in control. So you can set the permissions. You're in charge of promoting it, and you're in charge of testing it. If it's broken, no one's going to help you. Well, tech support maybe, but there's no sort of review team. Or you can submit it for publication in the repository, which is a higher standard. In that case, it's listed on our website. It's publicly discoverable. People will see it. But there's the review process for everything except the Packlet repository. So there's a higher standard, and we will test it, and it'll have to work. All right. So you always have to make a choice as you finish up of whether you want to cloud deploy it or submit it for publication. And my general rule of thumb is if you honestly believe it's something that's generally useful or interesting, then submit it for publication. Oh, great. Well, I've had a crash in 14 too. Okay, well, let me restart it. Coming up on time anyway. So I'll just say with my mouth what was on the screen, right? If you think it's generally interesting or useful, submit for publication. Go through the process. We have good reviewers that are really going to help you take your content and make it fit the conventions that we think are useful and helpful for everyone to use it. All right. So, and if you don't, if it's very very niche user base, it's really for 4 people and you know them all, then just cloud deploy it. Right. So, and as I was saying earlier, we have guidelines for every one of our repositories, and they're linked from the definition notebook. There's a button in the definition notebook to bring these up. So if you do decide to submit content, skim through these guidelines at least before you submit it, right? They're very helpful, and they will save you time, and they will save us time, and everybody will win. Right, so submitting content requires a publish ID. I've talked about this ad nauseum in tech conferences past, so go watch my other talks. But don't be scared by the publish ID. It's free, it's easy to create, and there's no reason to worry about it. All right, so I've basically covered this already, right? This is why you want to publish. I covered that above. I'm running out of time, so I'll move past. Also in this notebook, which I might be linked on the conference website. If not, I put a link in the chat to a cloud deployment of this notebook. You can make your own copy in cloud, or you can download the notebook from that link. So this is like the quick reference of, I have something interesting that people are going to want to see. Where should I submit it? How should I distribute it? And yeah, since I'm right on time, we'll go ahead to questions. And I also want to point out that these repositories are really useful, and you can tell that because lots of people talking at this conference are using them to put out the content that they're talking about. I did a quick perusal of the agenda, and I easily found 6 talks that are highlighting content from the repositories. All right, now I will see if there are questions. All right, for something that is extremely time consuming to compute, what do you think of a resource containing the computed value as well as having the code to compute the value if someone wants to spend time to do so? I'm having trouble understanding this. So I was having, oh, right, yeah, of course, yeah, that's a great idea, right? So, right, so so this problem of sort of caching computationally expensive results is like a fundamental problem of computer science. And it's a tricky problem, but it comes up pretty much in all of these repositories. So especially for like function repository, you might want to build caching into your function, right? There's once, which makes it almost trivial to do it, so that the first time a user uses it on their side, it'll compute it, but then it won't do it multiple times. But you can also, there's like memoization that you can build into a function in the function repository. And yeah, you have to think carefully about the use case. But it's often really good idea. All right, let's see. Peter's asking, say I've created a notebook for physics that has a demonstration in it, but also has a good deal of supporting documentation. Is this a candidate for demonstrations project, or would a different repository be better? Right, so the supporting documentation, if it's, right, so demonstrations has good support for like sort of written explanation that you might see in like a journal article, right? So you can like format equations really well and explain like the science behind the demonstration. What it isn't really good for is like sequences of inputs and outputs, like you might see in Wolfram language documentation. If that is really an important part that you want the end user to see, example repository might be the best case for it, right? You just have to make sure that the demonstration is somewhat elegant and readable and not just a big blob of code. Let's see, I'm coming up on time. I will stay here and keep answering questions. I have no problem with that, but I'll just plant a flag that anybody who wants to leave should feel free to do so. And obviously there are other talks, and I understand. All right. Dave asked, what is the best LLM to find things in Wolfram repositories? Oh, well, that's a great question. So what I'll show off here is from the tool repository. One of the tools we have in the tool repository is WFR search, or two of them, WFR search and WFR lookup. And if you're using an LLM through our tech, whether that's a chat book or through like chat object or LLM synthesize, you can provide these tools in your LLM configuration. And hopefully any of the LLMs will do good tool calling, and they'll know that they can look up in the function repository, at least, content that they can then use with a different tool like Wolfram Language Evaluator. So there's this, this ecosystem of tools that should be kind of LLM agnostic. Now, in practice today, GPT-4o is really good at this. Other people have used more LLMs than I have, and we have that website where we're breaking down, we're grading these things, and yeah, I would refer to that. But today, it's hard to go wrong with GPT-4o. It's a really good choice. All right. Let's see. Phil is asking, is there a strict requirement that demonstrations must have the head manipulate as opposed to, say, dynamic module? I think the answer is yes. If someone else happens to be here and can correct me, I see there's another person in the chat who is the worldwide expert on that question. So I'm going to say yes, but if the other person who I will not name in the chat wants to correct me, please do. All right. Ed is not asking a question. He's letting us know that it takes 10,000 computer years to compute extreme factors. Oh, so this is responding to the question about caching results. So yeah, in a case like that where he's talking about factorizing integers, maybe polynomials, probably integers, and the factors of an integer aren't going to change in 10 minutes. So if you've done that computation, yeah, by all means, keep the cached version stored. If it's something that depends on timestamps or whatever, then, or random values, obviously it gets much trickier and you probably don't want to cache. All right. And then, Ed is responding to Phil. And I think he's agreeing with me that you should have had manipulate. Of course, manipulates can contain dynamic modules. So usually you could figure out a way to have the manipulate on the outside and the dynamic module on the inside, and it would work just fine. All right, so that's okay. Now there's also comments in the chat. Same question from Audrey. That was on the other side. So I think I've gone through them. So thank you all so much for attending. Have a good time at the rest of the conference. I have another talk on a completely different topic on Friday, but if you like seeing this face, I won't be wearing my function repository shirt then. I'll be wearing a different shirt, but you can still see this face again on Friday. Thank you.